We are moving into the last section of the chapter, section 5.6, and it's really going to be continuing this idea of doing a lot of synthetic division, finding zeros. We're just going to kind of put it all together. So before we get into a little introduction of this lesson, I just want to recap some common skills that we've had. So when we've been finding zeros of a polynomial, we started out by factoring, which is going to be a great approach, and then we've kind of transitioned to also using synthetic division. You're going to notice today we're going to use a kind of a combination of those two. So with factoring, so this one is a difference of squares. So this is x plus 7, x minus 7. So my two solutions are positive and negative 7. So that was a difference of squares factoring. This one is a basic FOIL factoring. I need numbers that multiply to get negative 35 and add to get negative 2. So that's going to be negative 7 and 5. So my factors are x minus 7, x plus 5, which means my solutions are 7 and negative 5. These are also ones that if you graph them on your calculator, and we're going to talk a lot about the graphing connection, these would be the places where it crosses the x-axis. These are my x-intercepts. So for the synthetic division, first of all, we don't even know if it is going to end up being a factor. We don't know if we'll get a remainder until we work through it. So we're going to put our coefficients across the top, 6, negative 17, negative 4, and 3. We're going to divide by the 0 of this binomial, so that's 3. So we're going to drop down 6, multiply, add, multiply, add, multiply, add. What that means is that x equals 3 must be a solution or a 0 or an x-intercept of this. And what I'm left with when I divide is I'm left with a 6x squared plus x minus 1. If I want to see if I can find more zeros of this, I would have to either try to factor it, or I would have to go to the graph of it and see if there are any other places where it crosses the x-axis. So as we've been finding these zeros, we're going to run into something that we refer to as the fundamental theorem of algebra, which I've kind of talked about without giving it a name to this point. And what it says is the degree of the polynomial, which we started on day 1 of this chapter, degree is the highest exponent, will be the same as the number of zeros that a function has. So if a polynomial has degree 5, we're going to have 5 zeros. If the polynomial has degree 2, we're going to have 2 zeros. My zeros include anything that's real. Those are the ones that we're going to be able to see. And anything that's imaginary. Those are not going to be the ones that I can see. Keeping in mind, imaginary always comes in pairs. So you'll have maybe 2 imaginary, 4 imaginary, or no imaginary. The real ones are your x-intercepts. Your imaginary ones, again, come in pairs. We call them conjugate pairs or complex pairs. When I start referencing real zeros, solutions, roots, x-intercepts, they're all referencing the same thing. We're looking for those places where it crosses the x-axis. So when I look at a polynomial, I can tell immediately how many total zeros it has by just looking at the highest exponent. So for example, in this first one, my highest exponent is 4. That means that my total zeros is 4. And you do have to move around and look for the highest exponent. It may not be in standard form. So for example, if you look at the second one, the highest exponent is actually this term. So this is not in standard form. You want to look for that highest exponent to tell me the total number of zeros. And then same thing here. This one is in standard form. The highest exponent is 3. So that's the total number of zeros. Now, those total zeros could be real and could be imaginary based on what I see when I graph it. So you're going to start each of these problems by looking at a graph and seeing how many times does it cross the x-axis, how many are real, how many are imaginary. So that gives you a little introduction. I'm going to do the examples in the next video, but this kind of gives you an idea of what we're looking for today.